All right, so we are doing just a mini lab today. Okay, your lab report document is not going to look exactly the same as what I have on the board here because this is the full version of the lab. Okay, you will not have a design portion. Okay, you just have a problem. Well, actually, you don't. I think I even took the problem out, but you don't have to restate the problem. You just have to write it as it is there. Okay, so for our hypothesis for this lab, really, we're just testing Hooke's law. We want to make sure that that negative k times x thing equals a restoring force still holds up under practical conditions, right? So our hypothesis just needs to be something of that nature, okay? So the if part should talk about what Hooke's law says. The and part is we're going to put weight on a spring. And the then part should talk about what will happen as we increase the force on the spring. Okay, what will happen to the length of the spring as we increase the force? Okay, that's all we're looking for, simple thing. So the procedure, okay, going to be pretty straightforward. You're going to have your Hooke's law apparatus. They're all in those individual boxes in the big box labeled Hooke's law apparatus. Crazy, hey? Okay, so what you're going to have is this thing here, and you're going to need to put the measuring device, okay, that's this thing here, all the way to the top so it touches that little bar. All right, that way it is measuring the length of the spring with no weight on it. All right, so when there's no weight on the spring, we know it has a length of this much, whatever it is, right? Then all you're going to do is add weights to it using the slotted masses. All right, so what you'll have to do first is take the slotted masses off. Now, in order to do that, you can't just pull them off, okay? See, they don't come off. You have to bring them up to the thin part where the hook is, and then they come off, like so. See, they come off really easily when you get them up there. All right, but I've seen people like pulling and bending and trying to figure out why they won't come off. Just pull them up to the top and they slide right out. Okay, so you're gonna do that. You're gonna take them essentially all off. Just the apparatus itself is 50 grams. Okay, so you're gonna hang that on. That's your first trial. Everybody with me on that? Okay, then you're going to add on, it says 5 grams, so that's the really, really small one. Okay, put that on, put it back on. Okay, measure the length of the spring. Then it says put on, add an additional 10 grams. Okay, so we'll put on another 5. So that there's 10 on there, hang it on there again. Okay, put on another 5. Actually, you won't be able to put on another 5. You'll have to take a 5 off and put on a 10. For 15 grams because there's only 2 5s. Okay, and then you'll have to take, you'll put on another 5 to get it to 20, and then that's it. Okay, so you're going to do 50 grams, 55. Okay, so your force applied here in newtons, right, is going to look like this. You'll have 0, and then whatever the length is. Then you'll have 50 grams, 55 grams, 60 grams, 65. Okay, and sorry, but you're going to put it in newtons, so you'll have to multiply these numbers by newtons. Everybody with me there? Okay, so you have to you're not going to put in 70 grams. You're going to multiply 70, which is 0.07 by 9.81 to get your forces. Okay, then throw it in a graph. Okay, now to help you out, because you don't have to do the variables on this lab, the manipulated variable is going to be, well, actually the way we're doing it, it's force, but I want the graph to be reversed. All right, I want the graph to go the other way, so I want you to put distance on the x-axis. I know that sounds weird, but it's going to make the graph work the way I want. Okay, so distance on the x, okay, and force on the y. What should this look like that you've done before? Something. Good answer. Vague, but not wrong. Should be a linear graph, kind of like the rubber band one you did in Science 10. Right? Same graph, so it should work out similar to that because it's an elastic object. All right, questions on that? Okay, then just do the 3 analysis questions. Plot the graph, okay, calculate the spring constant. Remember that the units for spring constant are newtons per meter. That might have something to do with why I want you to make the graph with distance on the x-axis. Okay, and then the last thing is tell me what your y-intercept represents on the graph. Okay, that's it. That's all you have to do for the analysis. Then a conclusion, short, you're done. Everybody with me? Expectation is we get this done in class. It's not homework. Okay. All right. Grab what you need. Someone can use that one.